So what I'm going to show you now is,
You got a flash drive on that? And an SSD?
that one has an no, sorry, that one does not have an SSD. It will have, but this is my lab one. The production one that's going to be used has a shared SSD.
How much more, VMs do you need to run?
Remember, it's CPU bound. It's not disk bound. Yeah, it's not a. The number of VMs is dependent more on your resources. So if I had 6-core procs in there and jammed it full with the fastest thing I could find, well, probably about 70, 80, yeah, maybe more. I haven't benched it, so I know this workload on that target will do 25 developers. Right? Developers are nasty. Nasty people. Just because they're unpredictable, completely random, you never know what they're going to do. And it's funny. Okay, so this is transitioning to an external store. I'm sorry I missed a couple of slides. I'll explain them. But in this case, what we're going to do is we're going to take the storage, encapsulated storage VM, and transition it to an external store. So let's watch that. 2 hosts, VH2, 4. 4 is hosting the VM we're going to move. It's ES1. It's on shared storage, provisioned from itself. So in order to do this, we have to attach to some external store and mirror things. So what we're going to do is we're going to add 2 virtually compatible external LUNs hosted over Fibre Channel. In this case, it could be hosted over a variety of protocols, but in this case, happen to have Fibre Channel at home. I don't know why. Anyways, plugged it in, went inside of the OpenStorage VM. It's Open Indiana, 147. It could be Nexenta, doesn't matter. Same thing, same core, right? That's the important thing. If it was Nexenta, I could do this all from the GUI, but I've been at the command line forever, so it doesn't matter to me anymore. Okay, so I scan the available devices. I see them there. I attach them to the existing main store. You see the log file on there. Then I can see they resailboard. Everything's good. It's working. Great. I detach those 2 existing VMDK-based ones locally. And I remove my log because I can't move anything around while the log's on it. Right? So flush the I/O. And then you can see that it has completed, the log's gone. This is the slide. I'm missing some slides here. Before you can transition the VMDKs that exist locally, you've got to move them to shared storage and then move them to the target. I've missed those slides, I'm sorry. But anyways, I remove the 3 devices. We've got our primary disks, that's those 500 gig ones, and our ZIL. And there we go, we transitioned it over. You now see ES1 sitting on VH2, which is short on memory, but it still took it. All right, that's all I have for you. Any questions?
I have a pretty simple-minded question. So you're basically your servers that are running the hypervisor have direct attached storage, or is it ISP or Fibre Channel?
Yes, they're direct attached storage within the same box.
Then you run a virtual machine, which is the storage server.
Yes, it's the storage head. Yeah.
And it is then providing NSF service of the raw
Yes,
data to the other virtual machines.
Correct. So self-provisioning. So there are some issues with it, but it works.
That works better in some way than having a separate box, which is the storage server.
Very debatable. It's the feature sets that we're looking for. We're looking for features and flexibility. Is it the ultimate in performance? No. Could I do a better job on an external storage head? Yes. How much would it cost? More. So if you're exploring this and you want to see whether this is right, you can minimal investment. Buy 1 server, put it all together, light it up, examine your workloads, do all your head work, make sure you understand what you're doing before you move on. Then start investing in more. You can transition it to external. You can still provision it through a VM. You could completely provision it on the external device. You could import that data in those external devices by mirroring it off, and then import the ZFS array to an external store. Your flexibility is unbelievably, exponentially increased. That's why I do it. Because it makes it easy for me to change. And everything's changing so fast that you have to have that leverage. Otherwise, it's inundated. Well, hang on, we need to do an upgrade. Hold on, it's all physical. Oh, it takes time to do physical things. Virtualization allows you to move things around. Okay, I want to move it to that other storage server because I'm going to do work on this storage server. You got all kinds of options. You know, you're no longer constrained by, oh, hang on, you can't bring that down. Okay, when am I going to do that? Ah, how's midnight sound?
So you're at the lowest level, this pool of disks is being managed by the hypervisor, and it's got some data on there that it needs to protect that the storage manager doesn't see.
Right.
And how is that protected?
Okay. So strategies are for protection are an actual backup of the data. It's NFS. You can offline back it up. You can actually attach to the the VMs themselves and back up the actual content within file-based backup. You can mount stores and back them up externally, or you can replicate / mirror something off. That's the preferred method I have is Delta-based backups because of volume. So instead of backing up every single little thing on that box, what I'll do is I'll take a snapshot of the actual full storage subsystem, and then ZFS send it across to another storage head, to another file, file system as equal. That's my primary strategy, and I'll do that depending on availability. In the case of VDI, once a day I think would be enough, unless they have some really serious requirements for data, maybe continuous, where you're constantly replicating it. Or maybe you need everything there the same way as it was. You mirror it. Synchronous. There's a cost to mirroring it. There's synchronous replication or mirrored Z pool is kind of nasty, because if there's a problem on the target and it's waiting for it, everything slows down on the primary. So you have to be careful with that. Leaving it mirrored in that way, you got to make sure that channel isn't slowed down, degraded, etc. But primarily snapshots of your friend, ZFS sends of your friend. It's a crash recovery environment. We're not talking about transactional processing with banks or anything. It's availability is based on what the end user says is okay. If they say an hour of loss is okay, great. Replicate every hour. Like it's free. ZFS send receive is free. That's the nice thing about it. Any other questions? Okay, thank you.